Welcome to class. All right, so I think we just before we left for the break, we did postpone, the test. We said we're gonna do it next week. Okay, so today we're gonna finish what you have left in the chapter 6. We're gonna talk about quartile, what is a quartile, etc. Z-score quartiles, and then we're gonna go over the review for that test, that upcoming test. We're gonna go over the review together. Okay.
I'm sorry, my computer glitched. What day did you say we rescheduled the test for?
Yeah, next week.
Okay.
Next week. Yeah, next week. I mean, it's supposed to be today, but I thought, okay, right after the break, it might not be like a very, very good timing. So uh, that is why we're gonna do it in the first hour. The first hour next week. The first hour. So when we do the test after the first hour, we're gonna dig. We're gonna go over. We're gonna get the review out for the final exam. Either we're gonna do the review, like the official review, some of the problems, or either we're gonna go our own test. You see, that is a good review also. Our own test, the test we did, test 1, test 2, test 3. If you put them together, quiz 1, quiz 2, quiz 3, if you put them together, that is also a good test for the final exam. Okay? So either way, because the official review is like, I don't know how many problems in the official review, a lot, right? About 60 of them. So we cannot do like 60 problems. So when if you have time left, we're gonna now, by now, I think maybe we forgot about, chapter 1, chapter 2. I don't know how much we forgot about it. Okay. And the only problem for the final exam is the memory. That's it. It's not the questions on the final exam as the same level of difficulty than the questions we did in the test. It's the same level of difficulty. The final exam is not harder in that way. The only thing harder, yes?
When does class actually end?
Yeah, I mean, this class ends material-wise. Next week is going to be our last class material-wise. So the week after that is going to be the final exam, I think. Let me make sure about the final exam. So I have to go. It is on your syllabus, right? The syllabus. Yeah, the syllabus right here. It says
the last test is November the 30th, but we moved that to next week.
The final exam is way after, is below. It's when you keep going.
Isn't the final exam on the 14th?
Yeah, December the 14th. Yes, December the 14th is from 6 to 8. You see, from 6 o'clock to 8 o'clock. That's the final exam. Okay, I was saying the final exam is the same level of difficulty than the regular test. The only thing about it is you have to go back and refresh your memory about chapter 1, chapter 2, because it's going to be evenly, every chapter will be represented in the final exam. Every chapter will be evenly represented. So that's the only thing with the final exam. So now, like I said, the options to review for the final exam, you have the official review, which is a lot of problems, that is good. If you do all of them, that's good. Another way to review the final exam is if you go over the tests we did, right? You go over it by yourself. You try to do them by yourself. That is also a good way to review, right? The tests and the quizzes that we did in class. All right, so last time we talked about the Z-score, and we said the Z-score is a standardized way to measure how far you are from the mean, how far somebody is from the mean. And we use, for instance, we can use a Z-score to see, who, if we want to compare two people, right? from different instances. So we're gonna go back, we're gonna go ahead and try to give you a couple of, one problem about the z-score, right? So let me share my screen first. I hope now the stuff will be okay. All right. So first, let me pick up.
Can you record the class, please?
Yeah, I'm recording the class. Thank you very much for reminding me. I'm recording it. Insert.
Thank you.
Thanks. So we have this stuff. All right. So you see, that's, to say what is the z-score right here. If you take this problem out of the book, so we say the average. So I have to check if you guys here. Okay, you guys still here. All right. The average cost in dollars of a wedding in the United States, okay, not including the cost of a honeymoon, okay, yeah, is $26,650 with a standard deviation of 2,650. Find the corresponding z-scores of each score right here, okay? So we have somebody who did a wedding of 29,300, what is the z-score? Somebody who did a wedding of 10,750, what is the z-score? And somebody, etc., etc. So, and we said the z-score, like we said last time, was, the formula was z equals the data x minus the mean divided by the standard deviation, is the data minus the mean divided by the standard deviation, okay? What you said was the z-score. For instance, for the first one right here, z-score for the first data, 29,300. So basically, how far this guy, how far the cost of this wedding is from, how far away it is from the mean. How many standard deviations? How many standard deviations this cost is above the mean or below the mean, right? Okay, so what is going to be? We have the formula. It's going to be equal to what? 29,300 minus what? What is the mean? What is the mean?
2650.
Exactly. Another word for the mean is the average. This is a mean, right? Same thing. It's 26,650 all over what? What is the standard deviation? All over 2,650. That is a z-score. It is a score. It's like a credit score, okay? It is a score that we give to any data, okay? It is a score, right? It's like a way to see how many standard deviations somebody is above the mean or below the mean.
The food's here, love.
So it's going to be what? And then we take the calculator, we do the calculator, you see? The calculator is going to be 29,300 minus 26,650 equals, and then divide by 26,2650. That is 1, right? So let me repeat that. 29,300 minus 26,650 equals this, divided by 2650, that is exactly 1.
If you would like to.
Okay. The z-score for the first wedding is exactly 1. That means what? That means the z-score is positive, right? The z-score being positive means the data 29,300 is above the mean. How many standard deviations this data is above the mean? how many? Only one standard deviation above the mean, okay?
Yeah, they're the same.
So it is exactly one standard deviation above the mean, okay? That z-score for the first weighting is one standard deviation above the mean, okay? All right, so now, can you do the z-score for, this is a usual z-score, okay? This
Wait, I thought we had split
29,300, even though it is okay, this 29,300, even though it is above the mean, it is not like outrageous. It's not. This is not like outrageous, right? It's not like way, way, way above. It's just only one standard deviation above the mean. This is a usual z-score. This is a usual thing, okay? And for the next one, can you do it? For the next one, z-score for 10,750. Go ahead, try to do this one, please.
Oh.
All right. So how much did you get for the, what is the z-score of the second one? How much did you get?
-6.
-6. All right, you see, -6. So is, I kind of agree with it. So this is 10,750 minus 26,650 all over 22,650, right?
Yep,
And we get -10, right?
-6.
-6, okay, -6. You see, this one now, it is below the mean, right? Obviously, this data is below the mean, is way below the mean. Why? Because it is 6 standard deviation below the mean. That is an unusual standard deviation. That is an unusual z-score right here. If you look at the scale of the z-scores, if any z-score is between -2 and 2, this is what you know, people who do statistics, what they do. If you are here, if the z-score is here, this is the usual z-score. If the z-score is above 2, is right here. If the z-score is above 2, this is unusual z-score, above, right? Okay. Same thing, if the z-score is below -2, is also unusual z-score. Okay, this is going to lead you to what you call, depend how much it is, above or below the mean, it can lead to some, what you call, outliers, etc., etc. Okay, this is how we do the z-score. Now, z-score allows us to compare. So let me give you this one right here. I say, Mary scored a 83% in her class, where the average is 80% and the standard deviation is 2.6. Okay, now we say Jean scored a 78% in his class, right, where the average is 74 and the standard deviation is 1.3. Who did better in the respective class? Who did better?
So do you do the same scenario where you subtract 83 minus 80 and then divide it by
Yes.
the 2.6?
Yes, in the respective class. I mean, so no, I'm going to rephrase it relatively. I'm going to rephrase this. Relatively, who did better? Okay. If you say just who did better, of course, 83 is more than 78, right? But like I said, we cannot compare apple and oranges, right? Maybe the guy who scored 78, maybe the test was too hard, right? See, so we cannot just compare that. So the z-score allows you to say relatively, which means relatively, if we put everybody in their class, who did better?
Did Jean do better? The second one?
The second one? Okay, so we have to do the two z-scores, right? You did them?
I did them.
All right, you see, z-score for Mary, so I'm gonna let everybody do that, and z-score for Jean or Jean, right? And then we're gonna compare the two z-scores right here. Go ahead. I'll let you like a couple of minutes to do that, everybody. All right, so tell me, what is this score for Mary? Somebody tell me.
1.115.
1.15. Okay, what you did to get that to that number? What you did?
So I took 80. I took the 80. Can you go down just a tiny bit?
80.
I took the 83 and subtracted it from the 80, and then I divided it by the 2.6, and I got
Exactly.
1.15.
1.15, right?
Mhm.
This is a usual z-score is not above 2. That is usual. How many standard deviation? My data is above the mean, 1.15, right? Okay, that for Mary. For Jean, is what? What you did?
0.076.
3.076, exactly. So this is 78 minus 74 divided by 1.4, right? And you said 3.076, exactly. You see?
0.3.
You said how much?
1.3. You wrote 1.4.
Okay, 1.3. I'm sorry. You're right. 1.3. All right, so thank you. So obviously here, because Jean has a z-score above the mean, and here this is what we want, right? We want a z-score that is above the mean, okay? Then he has a bigger z-score above the mean, then Jean did better than Mary, okay? Sometimes, according to the context, sometimes it's better to be above the average, sometimes it's better to be below the average, right? Can you give me a context where it is better to be below the average? Can you give me a context where it is better be your score to be better if you want your score to be below average, for instance? It's not every time that we want to be above average, right?
Right.
If you are racing, if you do a race, right? What you want? You want to be above average or below average? Your time.
Below average.
Below average, right? If you are racing, you want your time to be below average. So in that case, having a lower z-score will be better, right? In the context of race, for instance, right? But in the context of a test, obviously in the test, everybody want to get above average, right?
Mhm.
It's a test. Unless if the test is scored like what? What score you have to negative scores? The more negative you have and the better you are. Is it golf or something like that? I never understood that. I never understood. Yeah, I think golf, is a more negative and the better you have, something like that. Or some, I even don't know. So, but in this case, for the regular test, we want to be above average. In that case right here, you see here the z-score for Jean is not even usual z-score. Is too much. Jean is too much above average. Okay. All right. So who did better? Jean did better.
The second one, right?
Yes, okay. The second one. All right, so that's the z-score. You see, frankly, if you remember, this is how we get the z-score. It's a very, very simple formula. Data minus the average divided by the standard deviation, frankly. So what next is just a, what next is just a arithmetics. So now to close this whole, chapter, we want to talk about 5 number summary. What we call the 5 number summary of data. Okay, so basically we're going to divide data, any set of data, we're going to divide it into what we call quartiles. Okay. Obviously, when we say quartile, we think about four stuff, right? We're going to divide each data in 4 pieces, right? So basically, again, what's the idea behind that is to better understand the spread of the data. That is the idea behind that, This is about like positions, stuff like that. The average, the standard deviation, the maximum, minimum, all that is about the range, is about the spread of the data. What is, what is the position? Oh, if you have my data here, if this is my data, I divide my data into quartiles. So first, the lowest number we call the lowest number is the minimum. That is the lowest number, lowest data, right? This one here is a maximum. That is the highest data, right? And then obviously, who do we have in the middle? How we call it? What is a guy in the middle? Is the middle the median,
Is that the
right?
mode?
No, the median. Remember,
Oh.
the median is the one exactly in the middle, right? And then we divide into quartiles. You see, this is quartiles right here. When you divide your stuff into 4 quarters, you have quartiles, right? The median, this one here is called quartile number 1. This one is called, the median is also called quartile number 2. This one is called quartile number 3, okay? And here you have maximum, here you have a minimum. Obviously, the median is the one is right at the middle, right? The median. And last time we saw how to get the median, right? Remember last time we saw how to get the median, okay? Now, the median defines the data into 2 halves, 2 equal halves. Basically, you have 50% of the data is here, and about 50% of the data is here. You agree with that?
Yeah.
That is the definition of the median, right? Now for the quartile is the middle of the middle, right? The first quartile right here. The first quartile is the middle of the first set. You see that set right here? That set right here? If you look at the median of that set, that is quartile number 1, okay? So it's gonna divide this one into 2. It's gonna divide it into 2 equal halves, right? Each one of them is how much percentage? 25%,
25
right?
and 25.
Exactly. You see, this is 25%. This is another 25%, right? So 25 plus 25 is 50, right? And the quartile number 3. The quartile number 3 will divide the other half into 2, right? That's the quartile number 3. It's going to divide it into 2 halves. So this one and this one right here. So this is 25, another 25%. This is another 25%, okay? So how much data is below the quartile number 1?
25%,
How much data is above the quartile number 1?
50%.
Look, you have to count all of them. You
Oh,
have
all of
25
them.
below, above quartile number 1. How much data is above quartile number 1?
25%.
Above,
No.
it's from here all the way to the end. How much?
Oh, 75%?
75%. Quartile number 1 put on one side 25% of the data, on the other side 75%. Quartile number 2, quartile number 2, aka median. How much is below the median?
50%.
50%. How much is above the median?
50%.
50%. Quartile number 3. How much is below the quartile number 3?
75%.
Exactly. And how much is above?
25%.
25%. Right? When somebody asks you write the 5-number summary, they're asking you to find those 5 numbers: the minimum, the maximum, quartile 1, quartile 2, quartile 3. Right? So the Q's start for quartile. Q1 means quartile number 1. Q2 is quartile 2. Q3 is quartile 3. Now, we're going to see an example, and we're going to see how to find the quartiles, right? Okay, so yeah, you're going to see it on the example, something like that. Find the 5-number summary of the following set of data. All right, so, okay, so let me go ahead and grab some data here. Go ahead and grab some data. So right here. This is my data. Not sorted yet. My data is not sorted, right? That is
can't
my
see it.
data.
Okay, there we go.
That is my data is not sorted yet. So you have to sort it out. Remember, every time you want to find the median, what you have to do first. If somebody wants to find the median, what do they have to do first?
From smallest to largest?
Exactly, from smallest to the largest, right? Okay, from smallest to the largest, if you want to do the median. All right. So we're going to do that. Do we do it or we just go and pick up the sorted data, right? So first, order that. First, order the data. Let's go and pick it up, right? From the book, so we can save some time. That is the order set right here. Let me pick it up. Right here. All right. You see, that is my sorted data, okay? What is the size of this data? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 24, right? The size of my data is 24. Okay, of the five number summary, who are the easiest to find after you sort it out?
The ones and tens. Well, the
The five
ones.
number summary is these five numbers right here. Minimum, quartile 1, quartile 2, quartile 3, quartile 4, I mean the maximum. Of the five of them, who are the easiest to find?
Minimum.
Obviously.
Right.
Say again?
The minimum and the maximum.
Thank you very much. The minimum and the maximum, we don't need no calculation for that, right? Who is the minimum?
1.
1, right? The minimum is 1, right? Who is the maximum?
35.
35, right? Everybody see that? Of the five number summary, the minimum and the maximum, after you sort the data out, after you sort it out, the minimum and the maximum are the easiest to find, okay? Okay, now I let you like about a minute for everybody. Then the remaining what? Quartiles one, the three quartiles, and 1, 2, 3, who is easiest to find? Who is easiest to find first?
The median?
Yes, the median, right? The quartile number 2, right? Go ahead. Find the quartile number 2. I let you like about a minute to find the quartile number 2, right here. Okay. Try to find the median. All right. What is the median? Somebody can come up with an answer.
6.5.
You said between?
6.5. 6 plus 7 divided by 2.
Okay, you said 6.5. All right.
Yeah.
Thank you very much. So remember last
Yeah,
week
that's
we
what I
said we
got.
have two ways. We have two ways to find the median. The first way is to cross out the numbers left, right, left, right, left, right, left. You know, that's the first way. Okay. The second way is to locate the median, to do the location stuff, right? Which is more mathematical. For instance, what is the size of my data? It's 24, right?
24,
I do
yeah.
24 plus 1, I divide by 2, which is 25 divided by 2 is 12.5, right? Since I have a decimal number, I don't have 12 exactly. Since I have decimal number, what I do for the median, I add up the 12th position plus the 13th position divided by 2, right? Okay, that is the median locator. Median locator, right? Or you can go ahead and just cross them out, left, right, left, right, left, right. So now I go the 12th position, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13th divided by 2, right? The median lies between these two. 6 plus 7 divided by 2 is how much? Is 6.5. You are absolutely correct, right? Okay, so the median divides your data into, you see, 1/2 is 50% is on the left of the median, 50% is to the right of the median. You agree with that? 50% of the data is the left side, 60% is right side. So now what you're going to do? To find the two remaining quartiles, I know the median is 6.5, is in here. You see, the median in this case is not a data itself. It's not like it is not present in that 6.5 are here. I have two sets. I have the left set and I have the right set. Okay. The median of the left set is quartile number 1. The median of the right set is quartile number 3. Everybody see that? The median of the red set is quartile 1. The median of the right set is quartile number 3. Okay, go ahead. Try to find quartile 1 and quartile 3 then. All right. So what is the median of the first set? The set on the left, what is the median? Somebody, is that the median for the first one? You said?
4.5.
4.5, right? Okay, let's check it out. So how many people on the left of the median? 12, right? You
Yeah.
have 12 people on the left of the median.
Yes.
So those 12 people, the median located says 12 plus 1 divided by 2, which is 6.5, right?
Yes.
So it means I'm going to add up the sixth position plus the 7th position divided by 2. 1, 2, 3, 4, 5, 6. These two right here, I divide them by 2, what I get? I get 4.5, right? 4 plus 5 is 9. 9 divided by 2 is 4.5. That is 4.5. And what is the quarter number 3?
11.
You got 11 exactly? Okay, so
I think so, yeah.
so again, you have 12 of them here. So we said 12, it's going to be 6 and 7s. 1, 2, 3, 4, 5, 6, 7. Well, hold on. 1, 2, 3, 4, 5, 6. And these two right here, 10 plus 12 is 22. Divided by 2 is 11. So that is 11. You see, these 5 numbers are what you call the 5-number summary. That's it. These are the 5-number summary. You see, it's like finding the minimum, maximum, and then finding 3 medians, right? You find the real median and then the median of each subset. Okay, that you call the 5-number. That is what we call the 5-number summary. All right, so let me give you another one here, and then all right, so let's do the one of these right here.
Are you there?
He's done.
He left us. Think he's still talking?
Might be that situation again.
All right. Oh, okay. So you guys want to tell me how we? So is my data sorted yet? Is my data ordered from left to from from small to big one?
No,
Not yet, right? So we have to sort it out. So can you tell me then? What is the first number?
5,
And then we have what?
6,
6,
And then
7,
yep.
8,
8,
Uh-huh.
9.
8 again,
Another 8, yes. And then
Oh, 9.
how many
2
nines?
9s. 2 9.
Nines, right? And then
10,
10,
10, and then
11,
11,
11. You
12,
have 12. You have
13.
13, right?
Mhm.
Yeah, and then you have
15,
15, and finally we have
16.
no, it's not finally. Oh, that's keep
No, it's
coming.
not. Yeah.
So you have
16
20
and 25.
and then 25, right? And let's check. We have 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? Okay. So since after we solve it out, obviously the minimum is 5, right?
5,
And the maximum is 25.
25,
Now the median, which is quartile number 2. How much is it? How much you got?
9.5.
9.5, right? So we have 14 data. You see, 14 data, 14 plus 1 divided by 2 is 7.5. So I'm going to add up the 7th position plus the 8th position divided by 2. Or remember, you always can do this, you can do this, right? Okay. This also works. All right.
I put it down.
This works also. You see, so we left with 1, 2, 3, 4, 5, 6, 7 plus 10 divided by 2, which is 9.5. The median is between these two, okay, which is the quartile number 2. This is 9.5. Okay, so it's going to divide my data into 2 sets, the left set and the right set. What is the median of the first or the left set?
8.
It's 8, right? This one we have 1, 2, 3, 4, 5, 6, 7. We have 7, which is odd. Odd is always easier. 7 plus 1 is 8. 8 divided by 2 is 4. It's going to be the one at the first position. This is quartile number 1, right here. And the other one, what is the quartile? What's going to be quartile number 3?
13.
13, exactly. That is this median 13. All right, so somebody is having some noise going on. So, all right, everybody sees how we calculate the 5-number summary. Everybody see that?
Yes.
All right.
Yes.
So this is how we calculate the 5-number summary. So, if you see that on an exam, okay. So look at the calculations. They are just some regular calculations. So now, if you go back and we take this stuff right here, the review, okay, for our upcoming test. We're gonna start with the chapter 6 problems, right? We're gonna start with chapter. Some of them we did in class, frankly, some of them we did in class. So just
Are they going to be on a test? Is this going to be on a test?
Yes, yes, this coming test, yeah, it's chapter, you know, it's going to be 4, 5, 6. You know, it's going to be some problem in chapter 4, right? And then chapter 5, something
Okay.
like that. And then chapter 6. Okay, so the first one right
Okay.
here, the first one is exactly in the book. So if I get the book out, right here, that's not that. It's chapter 5. Introduction, I think, or I think it's organizing. Is this one right here? Categorical data right here. Okay, if you have this one, that is the one I put on the review. If you have this one right here, construct a frequency table for this data, right? Okay, so construct a frequency table for this data, draw a bar graph, how many students participated in this survey, etc., right? So let us do that together. All right, I want to do a frequency table, right? So the frequency table, you're going to do 2 columns. In the first column, you do the category right here, or the data, and here's the frequency. So what are the categories? What is the frequency? And we can even add another one where we put the, just to remind you, the relative frequency. All right, go ahead. All right. For each category, we're gonna put, so we have the categories, they are Java. I'm just gonna, you know, the order here is not important here. Perl or Lisp, Perl, right? What else we have?
CTT.
C++, right? Okay. What is the frequency for Java? How many times do you see Java here?
9.
9. Everybody agree with 9?
Yeah.
Yes.
Okay. What is the frequency for Lisp?
3.
3.
3. The frequency for Perl?
11. Is it 11?
11.
11.
Yeah,
Oh, somebody said 12. Wait a minute.
I got 11 too.
12.
I got 11.
1, 2, 3, 4, 5,
11.
6, 11, right?
Yeah,
7, 8, 9, 10, 11, right? 11, 12. That's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12, right?
12. Yeah, sorry.
Yes.
They're all running together.
Yeah. And C++,
Yeah.
how much? How many?
6.
6, yeah.
That's 6,
Six.
okay. You see, one way, at least to say if I'm off, is to add up the frequencies, right? See, what is the total of the frequencies? This should be equal to the total number of the data here. And there's a very easy way to know here. They said, even if they said in the class, yes, I mean, in the problem, yes, even if they didn't say it, we can count. Each row is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times is 30, right? And
Yeah.
we just want to see if we get 30 here. 12 plus
Yes.
12, 24, we got 30, you see? So if we get exactly the same numbers, very likely we are right. You know, our count is good. So the relative frequency, do you remember what you have to do?
Yeah. You have to divide.
Exactly. 9 divided by what here?
30.
30.
30.
You see, is like, you know, 3 over 10 is 0.3, right?
Mm-hmm.
3 divided by 30 is 0.1. 12 divided by 30 is 0.4. And finally, 6 divided by 30 is 0.2. And when we add them up, we should find 1. 0.3 plus 0.1 plus 0.4 plus 0.2 should be 1, right? If somebody asks you the percentage, remember, if you want to transform a decimal number into a percentage, you multiply by what? You
100.
multiply by 100. Thank you. This is 30%. This is 10%. This is 40%. Right? This is 20%. In case, yes. In case we are asked to do that. Now the bar graph now. I put my categories here. You see here, to do the units here, I have to say what is my minimum, what is my maximum. You know, it's go all the way to 12. So if I have to choose like some small units, right?
Mm-hmm.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You know, it's go all the way to 12. So I choose some small units to make everybody fit. So I use Java here, you know, I take some space, so it's going to be legible. Lisp here, I say Perl here, and then C++. So Java is 9, right? You see? So, you know, the bar graph for the frequency. Draw a bar graph for the frequency, not for the relative frequencies, for the frequency. So it's 9. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this bar will be like this, like this. I draw a nice bar like this, okay? That's it for Java. Lisp is only 3. 1, 2, 3. It's like this. Now I managed to have the same size of the bars, right? Same width. Same width. So if I don't have the same width, then somebody could say, okay, what about the width? You know, what they mean. The width doesn't mean anything. It's 12, 10, 11, 12 right here. For Perl is 12. And C++ is 6, right? 3, 1, 2, 3, 4, 5, 6 is 6 right here. All of this. That is the bar graph, you see. So in the test, please, you know, do it a little bit nicely so I can grade properly, okay? You know, some students, they don't really think about the grader, you see. You have to think about the grader, you know, to make their life a little bit easier. So you do like nice stuff, you know, take your time, do a nice stuff. So when I grade easily, okay? All right, so this is one of them. The next one here in the review is 5.3. Now it is about, it's number 4. Let's go to number 4 here in 5.3. Right? So Okay, so now it's because this is quantitative. Now we can talk about histograms, right? That is my table. Create a frequency and relative frequency table to display the data. Let your first, now we're gonna put them into classes. Remember, into classes, because if you have quantitative data, if you don't put classes, each data can stand out as a category, right? But this is overwhelming. So to limit the number of categories, we can group them into class, what we call classes. Now, here, we don't have the choice of the first lower limit and the width of the class, the size. We don't have the choice because it is given to us, you see? I don't have the choice here because it's given to me. The lower limit is 3 and the class width is 2 right here. So I have no choice but to do what they have to say. So here I do like this, like this. These are my classes here. And this is the frequency. Okay? So now, remember, we said it's very, very important to do the right classes according to the width and to the first lower limit is 3, right? Because we have 3 here, right? These are the classes. Okay? As much as needed. So the first lower limit is 3, and the size is 2. The width is 2. Remember what I said. What is the next number, which is, if you want to avoid mistake, what is the next number that is easier to figure out to avoid
4.
mistakes?
5.
Is it, I'm saying, no, let me explain myself. Is it this number here or this number here? Which one is easier to figure out without, to avoid mistakes?
The one under the 3.
Exactly. If you want to avoid mistake, figure out that number first, because that number is just 3 plus what? 3 plus
3.
2. 3 plus 2. You see?
Oh yeah.
First lower limit plus the size. The second number, the second lower limit is what? Is equal to first lower limit plus the width. So to avoid mistake, and I advise you that to avoid mistake, figure out that number first. What is that number then? 3 plus 2 is
5.
5.
If that number is 5, that number will be obviously
7.
4.
Oh,
And
4.
the next,
Oh,
yes, the next will be 7. I agree with you. The next will be 9. The next will be 11 until we cover all the stuff. The next will be 13 if you need it, etc., etc. Right?
Mm-hmm.
You see? So this is going to be, if this one is 7, it's going to be 6 here. It's going to be here, what? 8. It's going to be 10. It's going to be 12. It's going to be 14, etc. As needed. Okay? We just go as needed. Everybody see that? Okay. Now, what is the frequency now? You have to count all the numbers between 3 and 4, including 3 and 4. So I'll let you do that for a couple of minutes.
Yep.
All right, so what is the frequency of the first class, 3, 4?
Is it
Two.
2?
Only 2, right? So I have 1, 3 here, 1, 4 here. Is that it?
Mhm.
That is
Yeah.
it. 2. Between 5 and 6, including 5 and 6.
5.
Everybody got 5, right? It's 5. 7 and 8, including 7 and 8.
8.
You agree with that? 8? Okay.
Yeah.
9 to 10.
5.
Got 5.
I got 5.
11 to 12.
4.
4.
I got 4. And that's it, right? We don't have 13. We
Yeah.
don't need that class right here. We don't need it. Okay. So that is a frequency table. So now create a frequency. So now let's do the relative frequencies first. A relative frequency. So what is the total number of data?
24.
24. So the first one is 2 over 24, which is 0 point how much? 0.0?
8.
0.03, right?
Right.
8. All right.
Okay, 2 over 24, right?
8.33.
Is 0.08, right? Okay. And then 5 over 24 is
0.2.
0.2, right?
Yes.
Okay, so we're gonna round, of course. 8 over 24 is 0.33, right?
3.
Something like that. So we're gonna round, okay? 5 over 24 is 0.2. And finally, 4 over 24 is
0.16.
0.16, right? Okay, that is rounded. So now create a frequency for a frequency histogram for the classes, for the frequency, frequency histogram. You're going to do that one first, right here. So remember, what numbers we put on the horizontal axis, what number we have to put? We put only
The classes?
no,
Or the
which one, which part?
frequencies?
No, which part of the
Frequency.
classes? We're going to put the classes, but which part? Only the lower
Oh.
limits. Remember that? It's only the lower limits, right? Only the lower limits. So if you have 3 to 4, so we have is 3 here, 4. I mean 3, and then we're going to put 5, and then we're going to put 7, and then we're going to put 9, and then we're going to put 11.
Can you move up just a little bit?
Yeah, like this. Is it like this? Or do I take another page? Okay, let me take another page. Okay, so
There you go.
all right, so this is what we put. We put on only the lower limits. We put only the lower limits only. That is the method we're going to take for our class. If you do other classes, they might pick something else, right? You see some other numbers to represent, but for our class, we put only the lower limits. Everybody, for the histogram, if it is about classes, quantitative data, you put only the lower limits, right? You see here, you don't see no 4, you don't see no 6, you don't see no 8, only you see 3, 5, 7, 9, 11, 13, right? That's it. So now here, we put our regular units, right? The units that, we have taken into account, the big number is 8, right? So now I can take some freedom, put higher, a bigger units, okay? So the first class, the frequency is only 2. That's the first class. The second class, the frequency is only 5, 3, 4, 5. Here, the bars here, they are adjacent. You see, the bar here, there is no gap between two consecutive bars, right? The third one is 8. This 5 right here, right? 6, 7, 8. The third one is also 5. And the last one is 4. All right, that is the frequency. I mean, that is a histogram for the frequency. If we say create a relative frequency histogram, it's going to have the same shape, only the units going to change, right? Only the units going to change. It's going to be the same thing right here. I'm going to put still 3, it's still 5, it's still 7, it's still 9, it's still 11, it's still 13. And here, instead of 1, 2, 3, 4, 5, what numbers I'm going to put? I'm going to put these numbers. They are more annoying to put, right? This is 1 here. This is 0.5, right? This is 0.1, 0.2, 0.3, etc., right? 0.4, 0.5, 0.6, 0.7, 0.8, 0.91, right? You see, that's the only thing, but it's going to be the same stuff. The first one is 0.08, which is very hard to find, very hard to figure out, right? It's about this. The second is 0.2. You're going to sum like that, right? The other is 0.3. You're going to sum like that. 0.2 again, sum like that. And 0.16, about sum like that, right? You see, the two histograms, they have the same shape. Okay, how can you, you know, you see, how does the frequency histogram and relative frequency histogram compare? They are almost the same. They are the same histograms. They have the same shape, exactly the same shape. The only difference is the units on the vertical axis, right? That's the only difference. But the shape is the same thing. You see, the third one is a peak. The third bar is a peak. The third bar is a peak. The next two bars, they are equal height. The next two bars equal height. The lowest bar is on the left side, the lowest bar is on the left side, etc. They have exactly the same shape. Okay? Everybody see that? This is how we create histograms, right? Again, for the classes, remember the classes, we're going to give you the first number to begin with, and we're going to give you the width. If we give you the first number to begin with and the width, the easiest stuff to avoid mistake, you have to figure out the second lower limit by just adding the first one plus the width, etc. Exactly as we did here. Okay, so we're going to take like a 10 minutes break. So when we come back, we're going to continue the review, right, on chapter 5, chapter 6 again. Okay, I think a lot of people did good on chapter 4, the factoring stuff, right? I think if you do the same thing you did on the quiz, it's going to be about the same questions on the quiz, but we're going to talk about it later. Okay, so now we're going to take a 10 minutes break and come back. All right. All right, so welcome back. So we're gonna continue here for the next problem, which is also like, you know, this is another representation of, this is stem and leaf, right? So let's see where we can find it here. All right, so that's the one we're talking about here. So all right, so the stem and leaf plot below shows the number of laps run by each participant in a marathon. Refer to the stem and leaf plot to answer the following questions. Remember, this is just another way to represent a data, but if you want to write them, all of them explicitly, right? You can go ahead and write all of them explicitly, okay? The number to the left is the stem. The number to the right, the numbers to the right are the leaves, right? So it's like a dozen and units, okay? Dozen and units. So here, if you have, for instance, the first row give me 16, right? The second row give me what? It's like nothing, right?
Yeah.
The two has no, you have a stem, we don't have no leaf, right? So the third row tells me, give me what? 30 how many times?
3.
3 times. And then we have 35, 35, right? So for the number one, the next row will be 43, twice 43, and then 48 is 4 times, 48, 48, 48, 48. And then this one gives me 50, and then 51, 51, 51, 51. And the last one gives me 62. If you want to write this explicitly, this is the data, okay? Construct a dot plot. Remember, dot plot is, we do the number, the line right here. We're going to put our numbers, right? We have 16, so it has to be respected now. The units have to be respected. Here I see I go from 16 all the way to 62, right? So maybe I can go with the dozens, right? 0 here, I have 10, 20, 30, 40, 50, and 60, right? Okay, so 16, I have only one data, which is 16. 16 is, this is 15, 60 down here, right? How many points I put? I only put one dot. Then 30, how many dots above 30?
3.
3.
That's exactly. 35, which is here.
2.
You have
2.
2. Exactly. 43, which is 1, 2, 3 here. That's 43 here. We have 2 of them. 48, which is about here.
4.
We have 4. 50, we have 1. 51, we have 4 of them. And 62, we have only 1. This is the dot plot right there. How many participants ran less than 48 laps? How many participants ran less than 48 laps? What numbers you're going to add up to get that answer? Isn't it everything from here up? Do you agree with me?
Yes.
Yes.
These are the data of people who run less than 48 laps, right?
Right.
So we can count them. We just count the leaves. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 people. How many participants ran at least 50 laps? At least 50 laps. It's going to be from what number to what number? When you say at least 50, it's going to be from
50 and down.
50 and more, right? Either 50 and more, it's going to be these right here. We're going to include 50 in it. 1, 2, 3, 4, 5, 6. Or, 1, 2, 3, 4, 5, 6. It's 6 people. What observation occurs the most? The mode, right? What observation occurs the most? You have two answers, right? You look at where you have the most dots. You have here and here, okay? These questions right here it is not like a surprising why it is almost calculation free, because again, this is like the beginning of the statistics. This is the beginning of it, right? Obviously, when if you do a statistics more than that, you're gonna see some stuff where you have to do more calculation, right? But here, it is about how to represent some stuff, okay? How to represent data. You see, it's not surprising why we don't have a lot of calculation. It's not surprising at all, okay? So that is, that is the next problem right here. So now, if you go to the next one, okay, this one where you have some calculation, 6.1, compute the mean and the median.
So the one, okay, no, go ahead. You're fine.
Oh, go ahead. So you had a question?
No, go ahead. You fine.
Okay. So this is I was saying there is absolutely no surprise why we don't have like some heavy calculation, because this is just how to represent data. We don't have a lot of calculation in this section right here. We don't have. You see, in the next section, you can have 6.1. You can have like how to calculate the mean and the median. How to calculate the standard deviation, right? Again, do we really do calculations to find the mean? No, you just add and you divide, right? The average, the mean, you add numbers, you divide by the number of terms. So for instance, if you take this one right here, we want to calculate how much is the mean. So let me put it here. Compute the mean right here. If you want to find the mean, do we need any ordering of the data? Just to find the mean, do we need to order the data?
No.
We don't need to order the data just to find the mean, right? We don't need that. Okay, so the mean, you add up all the numbers, you divide by the size of the data. You see, and I think everybody knows the mean, because in our daily life, we do a lot of means in our daily life. The average, you see, etc. So the mean is something. This is very that we encounter almost daily. So it's 19. If you are students, you have to know how to do the mean of your grades, right? To know where you stand, right? Where you stand at. So you have this 19 plus 55 plus 17 all over, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 over 14, right? That's going to be your mean. All right. It is mostly a calculator job, because everybody will use a calculator to add those numbers up, right? Compute the median. The median, we just did a lot of stuff. We have to order them. The first half of the class, we did the median. We did a lot of examples of the median. Okay, so we have to order the data, and then you have to order the data, and then locate the median. All right. So everybody in this class is confident. If you have the mean next week to calculate, you know how to find the mean and you have the median. Everybody confident with that? If you have something like that, if you have a data like that, are you confident you're going to find the mean and the median, right?
Yes.
Yeah, this is the basic of it, right? This is just the basic of this stuff right there. Okay, in these problems right here, you see, we say we give this. Now it's about the standard deviation. Okay, let's pick up this one right here. Let's pick up this one. And we're gonna show you how to find the standard deviation. Okay, so first, this is the data you have, 15, 10, 6, 15, 20, 12, etc., right? Find the range. Do you remember the range? What was the range equal to again? What you
It
do?
would be would it be 20 minus 6?
20, because 20 is the,
Highest number,
and 6 is the,
lowest number.
exactly. That is exactly the range. The range is the highest number minus the lowest number. It's 20 minus 6, the range is 14, right? You see, find the range is 20 as the highest minus 6 as the lowest, which is 14. We said the bigger the range is, we understand probably the more spread the data is. The smaller the range is probably the less spread the data is. This, this section 6.2 is about how spread your data is, okay? Is it like very scattered or is very compact, okay? Now the standard deviation now. This one has a little calculations in it, okay? But remember, for the standard deviation, we need to first and foremost, we need to find what for the standard deviation? We need to calculate what? The mean, exactly. For the standard deviation, you need to find the mean first, okay? Because remember, if you organize yourself as this, you put here the data, right? Which is 15, 10. Do we need them reordered, no order, in order? Do we need them?
No.
No, we don't. 6, 15, 20, and 12, right? Okay. And now we have to say data minus the mean. You see, we have to do that. So we absolutely need the mean here. And what is the mean? It's 15 plus 10 plus 6 plus 15 plus 20 plus 12 all over 1, 2, 3, 4, 5, 6, all over 6. How much is that? 78. 78 divided by 6 is 13, right? Am I right for the mean? I need somebody to tell me I'm right, so I don't continue with the wrong numbers.
It's 13.
It's 13. Thank you very much, right? So now we do each data minus 13, right? You see, you get what? You get 2 here and you square 2. 2 squared is equal to 4. Can you do the next steps, please? Everybody?
Is it 9 for the next one?
The next one is 10.
15.
It's 10,
Oh.
6, 15, 20.
Oh, I did 10 minus 13 and then I squared it and I got 9.
Yes, it's going to be 9, exactly.
Yeah.
Yep. That is right. All right, so you said the next one is 10 minus 13.
Is -3,
And
and you
negative
square that, and it's 9.
Thank you. The next one is 6 minus 13, which is,
-7.
and we square that, you get
49.
49, exactly. 15 minus 13 is 2. You square that, you get 4. 20 minus 13 is 7. You square that, you get 49. Finally, 12 minus 13 is a -1. You square that, you get 1. What you do next? Remember?
Do you add up the 4, 9, 49, 4, and 49 and 1?
Exactly. So how much you get?
I don't know.
116.
116,
Mm-hmm.
right? 116, exactly. So after you get 116, what you do next?
Divide.
Divide by
6.
6 as the number of the data, right? 1, 2, 3, 4, 5, 6. I said here, in OED2, they took only one option. If you go to another class, they will talk about two cases. Sometimes you divide by 6, sometimes you divide by 5, one less. But here, we forget about that. We just divide by the exact number of data. 3 plus 3 is 6, we divide by 6. 116 divided by 6, right, is how much? About
19.33.
19.33. And finally, what you do?
You find the square root.
Square root of that.
Exactly, square root of 19.33. That's going to be the standard deviation. And for that, we need a calculator. 19.33 square root, which is 4.39 or 4.4. Okay, that's the standard deviation. You see?
The third column is called the standard deviation, correct?
Say again,
So column 1 is the data, column 2
Uh-huh.
is the data minus the mean, and the third column is the standard deviation.
No, not yet. This is the square of that. This is data minus mean square.
Okay, thank you. That's what I wanted to know.
Okay, the next one is just the next steps is very hard to put them, to represent them into columns, because you put that number, you divide by 6, and then you take the square, right?
Okay.
All right, so you see, okay, of course, the standard deviation, the only thing about it is it can be annoying, right? Imagine you have like 30 data set. You see, you know how much you have to do. That's the only thing, you see.
Yes.
It could be, but in the test, I will not give you something that's going to take all your time, right? I will give you data, which is, regular size, 5, 6 or 5 or something like that. Because I'm not interested in, the long tables, okay? But everybody understands how we get the standard deviation. Everybody.
Yes.
Yes.
Yeah,
No. Yes.
You just remove this step. It's going to be same step in the next test. That's it. All right, you see, that is the next ones now. For the z-scores, we did, we opened up with the z-scores. So obviously, we opened up with z-score. We did this right here. So that was about the review of the test. Now, if you look at the first one, this about chapter 4, we did exactly this in the quiz number 3. And I have to say, a lot of people did it right. Okay, now it's a take-home quiz, okay? A lot of people did right because take-home quiz has less pressure. But pressure or not, if you have to factor sum like that, right? X squared minus 5x minus 84, right? The easiest way to factor it is to say, the easiest way to factor this one is to say, because this is 1 here, I'm going to be looking for 2 numbers. I open up my 2 parentheses. I put x here. I put x here, right? Are you going to say, I'm looking for 2 numbers. When you multiply them, you get negative 84. When you add them up, you get negative 5, right? I just keep looking, okay? Unfortunately, this is called trial and error method. You have just to keep looking for those numbers. You see, we said it's easier to start with the product. What numbers make up negative 84? And then we just keep looking for the couples, right? You see, what comes to my mind? Is it like 2 and 42? No. Is it like 3 and how much? 3 and 28? No, right? And we just keep looking. What numbers come to your mind? What numbers come to your mind? What are two numbers? You multiply them, you get negative 84. You add them up, you get negative 4. Or negative 5. What are those two numbers? Negative 84 is a high number, I agree, but you know. Do somebody have an answer? Do somebody has an answer?
Negative 12 and 7.
Negative 12 and 7, right? Thank you. Negative 12 and positive 7. When you add them up, what you get? You get negative 5. When you multiply them, what you get? You get negative 84. You see? So once you got those your two numbers, you got x minus 12, x plus 7. Now don't rush. Do not rush. Somebody who writes this, they're going to have full credit. Somebody who writes this, they're going to have 0. You see? You write this, you get full credit. You write this, you get 0. So, which means do not rush. Make sure you know, make sure the numbers you got are the right numbers. Okay. How to factor x squared minus 81?
X plus 9, x minus 9.
Thank you very much, because we call them difference of two squares. This is difference of two squares. So we know there is a formula, a squared minus b squared is a plus b, a minus b, or vice versa. So it's going to be x plus 9, x minus 9, or you can also write x minus 9, x plus 9. Doesn't matter which one comes first, okay? The second one, 36x squared minus 1225y squared. Does it fit in the category of difference of two squares? What do you think?
Yes.
It does, right?
Mm-hmm.
Because this is the square of what? 36x squared is the square of what expression?
6.
6.
X.
What? 6x. And the second one is the square of what expression? 5?
5y.
Y.
5y, exactly. So since I see that though, my answer will be exactly like the previous answer, 6x plus 5y and 6x minus 5y. All right? Okay.
Yes.
And the last one here in this category, to solve by factoring, x squared minus x equal 42. Solve, obviously going to be by factor x squared minus x equal 42. Before we factor, what do we need to have on one side?
The 40, you have to subtract 42.
In order to get 0 on one side, right? Everybody agree with
On
that?
the right side.
Exactly. Before we factor, I know what is coming. My way is a factoring. I know factoring is coming my way. But before I factor, I need to have 0 on one side. It's easier to move the 42. So I'm going to do that. I'm going to move the 42. I'm going to subtract 42 from both sides. So I get x squared minus x minus 42 equals 0. Now I go factoring. What are the two numbers again?
Negative 7 and 6.
Exactly. Thank you. It's negative 7 and positive 6. Am I done for this problem? Am I done?
No.
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 When we say solve, the only time we are done when we say x equals something, right? Or we say no solution. Every time we say solve, you are only done when you get x equals something, or you say no solution. The next step is to set x minus 7 equals 0, or x plus 6 equals 0, right? So I add 7, I get x equals 7, or I subtract 6, I get x equals negative 6. All right, so that is a review for this test, upcoming test. This is test number 3, very important for your grade. So try to do your best. You see, I mean, you know, frankly, everybody can score a good grade on this test. You know, I hope it's going to be like test number 2 for most of you. Test number 2 was good test for most of you. I hope test number 3 will be about the same or even better than that, right? So that's you know, that topic. Now we were saying now for the final exam, again, nothing is hard about the final exam. It's only about how fresh my memory is. That's only what is the problem with the final exam. For instance, if I go, I take our test number 1, right? Right here. That is our test number 1. You see, so we say solve an equation like that, right? Do I remember exactly the steps? I know this one, everybody will do it, right? But if you go to this one right here, do I remember exactly the steps? What is the easiest way to do it, etc., etc.? Okay? So that's the thing.
Okay.
For instance, if you look at problem number 2, what is the easiest way to do it? It's the easiest. In math, you always have a lot of methods, a lot of ways. But what is the easiest way to do it? This one.
Greatest common factor?
The
Exactly.
one with the X. Yeah.
The LCD, the least common denominator is the least, we call that the least
Oh, the
common,
least, I'm sorry.
the least common denominator, which is here 12. I'm going to multiply everybody by 12. You see, I multiply everybody by 12 in order to cancel the denominators, right? In order to cancel the denominator, I'm going to multiply everybody by 12. I put here times 12 here, times 12 here, times 12 here. At the top, I don't need to, I don't need top, bottom, I don't need that, only the top. Now, 12 times 1 is 12, right? 12 divided by 3 is how much? 4. It's going to be 4x, right? 12 times 3 is 36. 36 divided by 4 is 9. 12 times 5 is 60. 60 divided by 12 is 5, right? You see? When I do that, I get 4x plus 9 equal 5. Or, you know, you just can go ahead and simplify, etc. You know, you simplify here, you got 3 left. 3 times 3 is 9, etc. That is the easiest way to do it. Now, some people would do it with the fractions, is okay, but the easiest way to do this is this way. Now you have just subtract 9, you get 4x equal negative 4, and you divide by 4, you get x equal negative 1. Okay, that was part of our test number 1. This one right here, look, test number 2. Sketch the following line by finding any 2 points. We want to find points. It doesn't matter which ones. We just want to find points that work. Okay? We just want to find the points that work. So for instance, we can go ahead here. I can, since y is by itself, I can go ahead and assign values for x. I can go ahead and choose values for x and then calculate y, right? What is a nice value to choose for x? Give me an example, somebody. Look at the equation. What is a nice value to set for x?
0.
Thank you very much. 0 is a nice value to set for x. When I say 0 here, I put y is going to be equal to 3 over 4 times 0 plus 1. This is 0 is going to be 1, right? You see, 0, 1 is a good point. I have my first good point. Okay, go ahead. Give me another cool value for x to choose.
0.
X is already a cool 0, right? We already did that. Another cool value for x.
1.
Okay,
1, yeah.
Is 1 a cool value for x? You see, I mean, you can put 1, but I think we have some other value which has cooler
Two.
than 1. Even 2. You see, what I say that because here we have a fraction, right? It's 3. If you choose 1, you get 3/4 times 1 plus 1. Then you're gonna basically bother yourself with how to add fractions. Okay. If you want to avoid that, what type of value you can give to x? Avoid adding fractions. For instance, do you understand my point?
Would 3 work?
I mean, 3 will not avoid you, will not make you avoid the fractions. My point is there is some
4.
choices of x, exactly, some choices of x that are gonna help you avoid fractions, because if you choose x equal 1, you come to here. Some people can do mistakes from here going on, right? 3/4 plus 1. You see, what fraction is that? Then you have to do some calculation. Maybe you're gonna waste like 20-30 seconds of your time, right, to do this thing. But if you choose x equal 4, again, that is a choice. Look now what's gonna happen. We say 3/4 times 4. What's gonna happen to the 4th?
It's gonna go away.
They cancel out, and 3 plus 1 is
4.
4. Is this easier? But you know, you can choose any
No.
value. You can choose any value you want for x or y. You can choose any, but just these are choices. You can choose any value you want. But we go with the easiest choices because we want to graph. You see, I have 4, 4, and then I graph my line. Okay?
Okay.
Graphing lines. You have to go ahead and review how to graph lines. Okay? So right here, find the x-intercept and find the y-intercept and then graph the line. Here, you have to remember what you said. If you want to find the x-intercept, you have to set y equal what?
To 0.
Exactly. Set y equal to 0 and then solve for x. It's going to be 3x minus 2 times 0 equals 6. You get 3x equals 6. You get x equals 2.
Aiden, close the door.
So that is the x-intercept. If you want to find the y-intercept, you have to set what?
Y to 2, right?
If you want to set y-intercept, you have to set x equal what? I'm sorry.
0.
Thank you very much. X equals 0. You get 3 times 0 minus 2y equals 6. So we divide by -2, y equals -3. So this is y-intercept. And then we just graph them like this. Again, look at the amount of calculation we did for this example. Not much, right? Okay.
Is this going to be on the test for Tuesday?
No. That's
Oh, thank God.
That's for the final exam. That's for the final exam. You still have like about 2 weeks, right? For the
Okay.
final exam. So I think you have time to review for the final exam. I really do. So again, what we said here for the review for the final exam, you either can go ahead and do as much as you can from the big review, or you can compile the 3 tests we're gonna do. I mean the 3 tests we did. Test 1, test 2, the one we're gonna do next, and the 3 quizzes we did. If you combine them, that is also a good review for the final exam.
Can you go over one more thing? Can you go over applications of systems if I give you one of the examples from our homework?
Yeah, let me see. Let me get the homework right here.
What date is the final exam, Dr. A?
The Tuesday 14th, I think. Yeah, Tuesday 14th.
Okay.
Okay, so system of linear equations.
Applications of systems and
Okay, which one is it? Number one.
Do one, any of them, because I got them all wrong. I'm doing the application wrong.
Me too.
So if you could just help me understand the application.
Yeah, so this is how we set up the equation. Everything about how to set up. Now, something which is not about the math itself is to know the topic. To know the topic you're talking. For instance, here they're talking about the interest. You have to know something about the interest. If you don't know nothing about the interest, it's going to make it hard. Not the math itself, but the topic itself, right? For instance, this one right here is talking about the interest. If we don't know how to find the interest, It's just going to make the problem harder than it really is, okay? If you know how to find the interest, it's going to make it easier. So, for instance, we have this one right here. Okay, so this is talking about the interest. Anyone knows how to find the interest? What is the formula for the interest? Somebody knows? The interest is?
Can you repeat that?
Do somebody know how to find the interest? What is the formula for the interest?
It's principal times rate. It's interest times principal and rate.
No, it's principal times rate times time, right?
Okay.
PRT. Principal times rate times time, okay? Ngok invest a total of 20,500. We said, and one of the ways to do it is to organize ourselves like that, you see?
Mm-hmm.
So into two accounts. So we say the first account at 11%, right? And the second account at 4%, okay? And here's the total right here. So the first one right here, we don't know how much, we have two accounts basically. This is account one, account two. We don't know how much money he puts here. We don't know how much money he puts here, right? We don't know.
Right.
Okay. So here, the amount in each account, amounts here. Since I don't know how much he put in the account at 11%, I don't know how much. I'm calling X dollars, right?
Mm-hmm.
Okay, X dollars. Since I don't know how much he put in the account at 4%, I'm gonna call it Y dollars, right?
Mm-hmm.
Now, what first equation? When you add up X and Y, how much you should find?
So you would set it up X times 11%.
Yeah, we're gonna come back to that. But
Okay.
first, I mean, we're gonna come to that, to the next column. But first, the first column right here. When you add X and Y, how much you should get?
20,500.
Exactly, because X and Y is how much, is a breakdown of 20,500.
Uh-huh.
That's the total. So my first equation is X plus Y is equal to 20,500. That's my first equation, right?
Uh-huh.
Now I go to the next equation, which is about the interest. Okay, exactly what you were saying. The formula for the interest is the principal multiplied by the rate, right?
Right.
This account is 11%. So what is the principal? How much money you have in the account? How much dollars you have in the account?
X.
You have X dollars. You're going to multiply X by what? 11%. What is the decimal value of 11%?
0.11.
0.11x. That is interest, right? Everybody see that?
Mm-hmm.
The account at 4%, the rate is 0.04, right? We're going to multiply by that the amount we got in this account, which is Y dollars, right? It's going to be 0.04Y. Okay? These are the interest. And they are dollars. This is money. When you add them up, how much you get? What is the total interest?
15%.
1,700.
1765.
Yeah.
Oh, okay.
And that's going to give you the second equation. The
Right,
second is 0.11x
Mm-hmm.
plus 0.04y equal to 765, right? And now your system is set up. Now you solve it. You have three methods. The graphical method that we don't like, obviously. I don't like it. The substitution method or the addition method, right? This one is very good for substitution, okay? This type of system, they are very good for substitution. From the first one, we're gonna say, for instance here, we're gonna say y equals 2500 minus x. Everybody agree with that?
Mm-hmm.
When you subtract x from both sides, right?
Yeah.
We're gonna take this, we're gonna substitute it into the y here. Gonna be 0.11x plus 0.04, and then we open up the parentheses, 20,500 minus x equal to 1765, and just we solve. Okay, so we're gonna distribute, right? We're gonna 0.11x plus 20,500 times 0.04, 20,500 times 0.04 is 820 minus 0.04x equal to 1765. We're going to group these two like terms right here. How much is 0.11 minus 0.04? We take no chance. We use a calculator, right?
07.
Is 0.07. Thank you. X plus 820 is equal to 1765. We're going to subtract 820 from both sides. So we get 0.07x is equal to, right, 945, right? And then we divide. So x equal to 945 divided by 0.07. Okay, 945 divided by 0.07, and we get 13,500. That is how much he got. That is how much he put into what account? Into the account at 11%, right? That X, that is 13,500. Now, obviously, if he puts 13,500 in the first account, how much he's going to put in the second account? What should you do? What should you do?
Wouldn't you subtract the 20,500
Exactly.
subtract 13,500?
Exactly. It's 20,500 minus 13,500, which is 7,000.
Can you move it up a little bit, Professor?
Yeah, it's 7,000. I like this. Okay.
Yes.
So X is 13,500 and Y is 7,000. Again, if somebody does not know exactly how to calculate the interest, they cannot do this stuff. Okay. We used a formula which is not in the math itself. You know, that is which is not in the system of equation itself. That is like outside formula. Okay.
But the
So that
videos
is-
in the homework, trying to follow the videos, they were getting rid of the decimal, and I was getting lost when I got rid of
okay.
the decimal.
You see, that is an option. You see, because right here, that is an option. I don't think it's necessary here, because if you have this one right here, somebody can tell, okay, I don't like decimals. If you wanna get rid of the decimals, you gotta multiply everybody. The second equation, you gotta multiply by what number to get rid of all decimals.
But you got to move
somebody-
the decimal over 2 spaces, and then you're adding 2 zeros to the 1765.
Exactly. This is equivalent to multiplying the whole equation by what number? Exactly, to do what you said. To do exactly what you said, moving the decimal point to the right two digits is equivalent to multiply by 100. You see, you multiply each term by 100, which means you don't have no decimals. But I don't think this is just because it's not necessary. You know, you do that if you don't like decimals. In this case, we don't care. You know, for the money stuff. Remember the money? You know, the dimes, the quarters, stuff like that. Okay.
Yeah.
So, you know, remember we said we have the choice to consider the dollar, or you have choice to consider the cents, right? If you consider the dollar, 1 quarter is 0.25. If you are counting in dollars, 1 cent is 0.25. Okay, one quarter. If you are counting in cents, 1 quarter is how much then? 1 quarter
25.
is how many cents? It's 25. You see?
25.
You see, because, you know, working with full numbers, whole numbers is better than working with decimals. But I would not spend a lot of time just explaining that, because that's just an option. Okay? It's just an option. You know, somebody else can say, okay, I don't care about decimals. I just went ahead and like here, what we did here. All right. So that is,
So you
you know,
said there were
that
3 ways of doing it. So you just showed me one, and then we just described another one. What's another way?
now, I mean, so here, since you are not compelled to use one way, you choose the
Uh-huh.
one which is the easiest in this case, which is substitution. Now,
Okay.
if you go to the topic itself, how to solve systems, you remember we have like 3 sections. You have like 2.1, 2.2, 2.3.
Yes, yes.
2.1 was you using graphing, right?
Uh-huh.
So 2.2 using the substitution, what we did here, and the 2.3 using the elimination method or the addition method, okay? But in this case, you know, we don't have to, you know, we just choose the one which is like, it goes very quickly, which is substitution in this case.
Okay.
Right? Now, if you go back to the reviewing, if you go back to the reviewing the whole test right here, for instance, right here, you see, solve by substitution, you see? Okay, you see this one? Solve by what?
Addition.
By addition. Remember what you said here? This I look at this system, I say this system is very good for addition. Can somebody remind us why we say this system is good for addition method? Can somebody remind us why?
Because the 3y and the plus y, they cancel out, so it'd be
Exactly.
9x.
Yeah, so, you see, you remember it. Exactly, you remember it. Okay, so this system is very well set up for addition because when I look at the variable y, I see -3 and +3 in front of them, right? So when I add them up, the y is going to collapse, right?
Right.
And then we get 5x plus 4 is 9x, and the -10 plus 19 is 9, right? Okay, and then we continue. This one right here, when I look at it, is it very well set up for addition yet?
No.
Not yet, but can we do something to make it good for addition? Can we do something?
Yes.
For
Multiply-
instance, we don't add 1. We don't
Multiply by 1.
Multiply by?
By 3?
What equation? The first equation or the second equation?
The second 3.
Thank you very much.
First one, yeah.
Exactly. If you multiply the second equation by 3, then it's going to be 7x plus 3y equal -4 for the first equation, and the second equation becomes 6x minus 3y equal to -9. You see, now I have good now. You see?
Oh, yeah.
Now I can go ahead and add them up. I get 13x equal to -13. I divide by 13. I divide by 13. I get x equal -1. After I get x equal -1, I choose either one of the equation to substitute to get y. For instance, I can, the first one, I put 7 times -1 plus 3y equal to -4. That is -7 plus 3y equal to -4. I add 7, I get 3y equal 3, and then I divide by 3, I get y equal 1, right? That is the addition method.
Yes.
You see, opposed to substitution method where you get one variable by itself and then you substitute on the other one. You see, for instance, here we say solve by substitution. Substitution means you have to get one variable by itself, right? In either one of the equation. Now look at the 2 equations. Which equation is easier to use for substitution method? And which variable is easier to use by itself, to get by itself? The x. Thank you. The x in what equation? The first or second?
The first equation, right?
The first one. The first one here, I see x is almost free. The x, it has 1 in front of it. So for the sake of easy calculations, it's easy to take this one. I add 2y, so I get x equal 6 plus 2y. Now, what I'm going to do is that I'm going to take this whole thing, I'm going to put it here. You see, it will be 3 parentheses 6 plus 2y plus 7y equal 5. We distribute, get 18 plus 6y plus 7y equal 5. This is 18 plus 13y equal 5. Subtract 18, we get 13y is equal to -13. So we get y equal -1. After we get y equal -1, how we get x? What you do?
substituting.
Uh-huh.
Again.
Back substitute here, right here. I put x equal 6 plus 2 times -1, which is 4. Right? So these are the substitution method. Okay. All right. So prepare. So when we come next week, we're gonna do the first half of the class. We're gonna do. Please don't come late. Okay. If you come late, we're not enjoy the whole, the whole hour for the test. Okay. The first half, we're gonna do the test on Teams. Me watching, and then when we're done, for those people who want to stay to do some review, we're gonna do some review. If you don't want to stay, this is like the last class. You can check out, right, for the next time.
So next week is the final?
No, at all. Next week is test number 3.
Oh, okay.
Final exam
Gotcha.
is 1 week later. The final exam is 1 week
Gotcha.
later, is the 14th. The final exam is from 6 to 8. You see, our regular class start at 5:45. The final exam will start at 6 o'clock. It's gonna run for 2 hours. You will have 2 hours to do the final exam.
Okay.
Yeah, obviously, I think that, some people are gonna be done like very early, but you will have 2 hours for yourself to do the final exam. All right, everybody.
Okay.
All right, so prepare
Yes.
yourself. Prepare for the test number 3. It is worth 15%. I encourage you to do, again, I have the feeling everybody can have a very, very good grade in the test number 3. You see, I have the feeling that, the same thing with test number 2 can happen again. So prepare yourself. You can score a good grade. It's going to give you the drive, for the final exam. All right.
About how many questions is it, Professor?
Yeah, it's the next test number 3.
Yes.
Yeah, regular, 11, 12, something like that, 12, 13 maximum,
Okay.
Yeah, it's just a regular question, a regular amount of questions. For sure, for 1 hour, you will have more than enough to do that.
And for the test?
For the final exam?
Yeah.
The final exam, you will have 20 questions for 2 hours.
Okay.
That is really fair. Each hour,
Yeah.
10 minutes, that's fair. Yeah. All right, everybody. So dismiss early class a little bit today. And please don't miss the test next week, okay? Please don't miss the test.
No.
And do not hesitate to email me if you have some questions, all right?
All right.
Okay.